All right, this is chapter 4, lesson 4.2, patterns and linear functions. So our objective in this lesson is to identify and represent patterns that describe linear functions. We've got a linear function over here on our left. All that a linear function means is that it is a line. So our graph is a line. As you notice, all three of these are lines, okay? And then we've got some patterns on the right. So we are going to try to be noticing patterns in our linear functions. All right, so we got some definitions, of dependent and independent variables. The dependent variable changes in response to another variable, which is the independent variable. So we're gonna use the x-axis to label our independent variable. That's the one that's changing. And we're going to use the y-axis to label our dependent variable, which is the one that's reacting to the independent variable. Okay, so we're gonna represent geometric relationships. In the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Okay, so first off, let's go ahead and calculate the perimeter for each of these. So in the first one, we've got one side with 6, one side with 1. So the opposing side of each of those, so this side length is 1, this side length is 6. So our perimeter is going to be 1 plus 6 plus 6 plus 1. Okay, and this will give us 14. So that's our perimeter. For the second one, we've got 6. This side is now 2, 1 plus 1. So this side is also going to be 2. And then this side is also going to be 6. We've got 2 plus 2 plus 6 plus 6. That's 4 plus 12, which is 16. The next one, we've got 3 triangles. What is the perimeter of this one? We've got 6. The top side altogether is going to be 3 units. So the bottom side is going to be 3. And then this side over here is going to be 6 as well, okay? Since it's a rectangle. So we've got 6 plus 6 plus 3 plus 3. Okay, this is going to be 12 plus 6, which is 18. Do you see the pattern yet? Okay, the next one, we've got 6 on one side, which means that this side over here is going to be 6 as well. 1 plus 1 plus 1 plus 1 is 4, and we've got 4 on the bottom as well. So we do 6 plus 6 plus 4 plus 4. So this 6 plus 6 is 12. We got 4 plus 4, which is 8, and we end up with 20. Now I'm pretty sure you guys see the pattern, okay? So now we're going to put it in a table. Then we're going to describe it in words, and we've got to make an equation, and then we've got to make a graph, okay? First one, we had 1, then we had 2, then we had 3, then we had 4. That one's going up by 1. Excuse me, it was 14, then it was 16, then it was 18, and then it was... So our input here would be the one rectangle, and then our output would be the perimeter, so it's 14. Input was 2 rectangles, output was 16 as the perimeter. Our input was 3 rectangles, our output was 18, so on and so forth. All right, so first off, the number of rectangles. So in our, one slide too many. So our first one was 1, then we had 2, 3, and then 4. The perimeter, y. So we just calculated that. For our first one, it was 12, 20. So we have 14, 16, 18, and 20. And then the ordered pair, we're going to write it as x comma y. So our independent variable is x, and our dependent variable is y. So let's go ahead and write it out. Our ordered pair for the first one is 1 comma 14. Our ordered pair for the second one is 2 comma 16. For the third one, it is 3 comma 18. And for the fourth one, it's going to be 4 comma 20. Okay? Now, the reason we wrote it as an ordered pair is because we're going to go ahead and graph this, all right? So let's draw a y-axis. That's the vertical one, y-axis. And let's draw an x-axis. That's the horizontal one. All right, let's label our axes. So our x-axis is going to be our independent variable, and that's going to be the number of rectangles. So let's go ahead and label it. Number of rectangles. Our y-axis is going to be the perimeter. So let's label that the perimeter. Okay. Now, next thing that we want to do is we want to come up with a method to space these out, or like spread them out. So for example, on the bottom, on the x-axis, since we're only going up by 1 each time, I'm going to use 2 units or 2 spaces for each unit. So this will be 1, over 2 will be 2, here's 3, and here's 4. Now our x-axis only goes up to 4, so that's basically all we need to label. For our y-axis, we go from 14 to 20, so I'm going to count by 2s, okay? So we're going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, that's as high as it goes, so let's leave it there. At 1, we had 14, so let's find 1 on the x-axis, that's right here. And let's go all the way up to 14 in the y-axis, that's right here. And let's plot this point. The next one that we've got is 2, 16. So let's plot that one. Go 2 in the x direction, or in our horizontal axis, and then 16 in the y direction, that's right here. 3, 18, that's going to be right here, over 3, up 18. And then the last one, 4 in the x direction, and then 20 in the y direction. That's going to be all the way up here. Now, remember, this is a linear relationship. Each time we increase by 1, the number of triangles are increased by 2. So when we connect all of these dots, we should get a straight line. And we do. Perfect. Okay? So our previous example, okay? Time. Oops. Okay, so a function is a relationship that pairs each input value with exactly one output value. So whatever your input is, okay, that's going to be your independent variable, and then it's going to go through the function, okay, whatever it may be, it'll be an equation, and then it's going to output your dependent variable, okay, which will be whatever that is. Now, if we look back, all right, now what a linear function is a linear function is a graph that's just a line. So it's non-vertical, or it's part of a non-vertical line. So go ahead and circle this one. Of these 3, that is the only one that is a linear function, okay? Has to be a straight line. All right, so the table shows the relationship between the number of photos you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. Cross out an equation. We're gonna skip equation for now, okay, for all of these examples. So let's take a look first at the x, the number of photos. I notice it's going up by 1 each time. It goes from 0 to 1, from 1 to 2, oops, and then from 2 to 3. So it goes up by 1 each time. Now on the right, the y column, that one's going down by 3 each time. Okay, it goes from 512 to 509. Then from 509 to 506, from 506 to 503, so on and so forth, okay? So our first thing that we need to do is we need to describe the relationship using words. And it seems like every photo you take, the memory decreases by 3 megabytes. So every photo we take takes up 3 megabytes worth of memory. Okay, and then we also want to describe it using a graph. So we got to go to the next page and then let's graph. Our x-axis is the number of photos, y-axis is the memory. So for the number of photos, we have 0, we have 1, we have 2, and we have 3. So we only have 4 values that are close to each other. Y column starts at 512 and it goes all the way down to 503. So I'm going to start some. All right, so we're going to represent the linear function using a graph. Let's do this and this. Here's my y-axis. Here's my x-axis. Okay. Now we do have to label each. So let's go those. And okay. So our dependent variable is the memory and our independent variable is the number of photos. Okay, so let's go ahead and put 0 here. Here's 1, 2, and then 3. And that's what we're going to use to plot it. Okay, now around 500. Now, it would take a really long time to write all of the numbers up to 500. So what we do here is we include what's called a break. Okay, and a break appears towards the bottom of whatever axis you're using. So in this case, I'm using the break for the y-axis. So I'm going to put a little zigzag here. Okay, and that means that we're skipping all of the numbers up to the number that I put on the left. So over here on the left side, we're going to start at 500. So we're going to start at 500. Here's 501, 502, 503, 504, 505, 506, 507, 508, 509, 510, 511, and 512, okay? So all the way up. Now at 0, as I said before, our megabytes was 512 megabytes worth of memory. So we're gonna plot that point. At 0, we had 512. And then at 1, we decreased to 509, so that's gonna be right here. At 2, we went down to 506. And then at 3, we were all the way at 503. Oops, that was the wrong one. This is 3. Okay? If we drew a line through these points, it would be straight and it's decreasing, okay? So the more photos you take, the less memory you have to use, okay? That's the relationship here. Because the more photos we take, the more memory we have used, so the less memory we have left. Okay, that's why the arrow is going down. All right. Seems like we're pretty good. Go ahead and try the lesson check. Okay, the answer these on your own. Any ones that you don't understand, listen to or watch this video so I can go over them with you, okay? So the lesson check. Graph each set of ordered pairs. Use words to describe the patterns shown in the graph. So for A, we're going to plot 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. Okay, so remember, whenever we're graphing, we always want to have an x and a y-axis. So I'm going to go ahead and put my y-axis right here, my x-axis right here, label them x and y, and then I will plot 0, 0. That is just the origin, or where the axes meet. So we go over 0 and up 0. 1, 1, so that was 0, 0. 1, 1 is going to be to the right 1 and then up 1. So that's right here. This is 1, this is 2, this is 3, this is 1, this is 2, this is 3, so on and so forth, okay? 2, 2 means we go 2 in the x direction and 2 up. So let's go 2 in the x direction and then 2 up, that's going to be right here. 3, 3 is going to be right here. And 4, 4 will be right up here. Use words to describe the pattern shown in the graph. This appears to go up 1 each time we go over 1. So an increase in the x direction means the same increase in the y direction, okay? All right, B. This was A, by the way. B, let's go ahead and do the same thing. Let's create our graph. And the x-axis. This is the y. And let's go ahead and plot our points. So our first point is at 0, 8. So in this case, I'm going to go ahead and count by twos. So 2, 4, 6, 8. 2, 4, 6, 8. Okay? So at 0, 8, that's going to be in the x direction, we're moving 0. So we're not going to move at all. We're just going to move up to 8. So right here on the y-axis. Okay, and then we've got 1, 6. So we're going to move to the right 1 and then up 6. So it's going to lie right here in between 0 and 2 in the x direction and all the way up to 6. Then we've got 2, 4. Then we've got 3, 2. And 4, 0. So if we were to describe this using words, it appears that every time we increased x by 1, we decreased y by 2. So we're going down 2 whenever we go over 1. Okay, C. We've got 3, 0, 3, 1, 3, 2, 3, 3, and 3, 4. C. Oops. Here's my y-axis. Here's my x-axis. X, y. And let's go ahead and plot our points. So our points are at 3, 0. So let's move over 3. Let's go back to using 1 unit on the graph is going to correlate to 1 unit in general. So 1, 2, 3. And remember, we're shifting over 3 units and then 0 up. So 3 units, 0 up is going to be right here. Next one is going to be 3 units over in the x direction, 1 unit up in the y. Right here. Next one's going to be 3, 2, 3, 3, and 3, 4. Here's 2, here's 3, and here's 4. So this appears like it's going to be a vertical line, which means it's a nonlinear function. Okay. Number 2, use the graph below. So copy and complete the table showing the relationship between the number of squares and the perimeter of the figure they form. Okay, so with 1 square, our perimeter is 4 because we have 1 unit on each side. So our perimeter is adding all those together. So we get 4. There are 4 sides. With 2 squares, we've got 1, 2, and 1. So that would be 1 plus 2 plus 2 plus 1, which is 6. Okay? Let's see if we can notice a pattern. With 3 squares, we've got 1. 1 plus 1 plus 1 is 3. 3 and 1. 3 plus 3 is 6 plus 2 is going to give us 8. So this value over here on the right, next to 3, is an 8, okay? And I noticed a pattern. Let's see if you guys do. At 4, we're going to have 10, okay? Now, at 10, how many are we going to have? Well, I noticed at 1 we had 4, at 2 we had 6, at 3 we had 8, at 4 we had 10, at 5 we're going to have 12, 6 we're going to have 14, 7 we're going to have 16, 8 we're going to have 18, 9 we're going to have 20, and then 10 we're going to have 22. Okay? So when we get all the way up to 62, it wants to know the number of squares it will take in order to reach a perimeter of 62, following this same pattern. The number of squares that it will take is 30, and then n. So if we don't know the number of squares, but we represent it as the variable n, what will the perimeter be? Well, I noticed that each of these, so let's say we'd have 1, you added 2, so we started with 2, and then we're adding 2 times whatever the number of square was. So plus 2n. So for example, if we use 2, that would be 2 plus, what's 2 times 2, which is 4, that gives us 6. 2 plus 4 is 6. 3, this would be 2 plus 2 times 3, which is 6. 2 plus 6 is 8. Let's use 4 for n. 2 plus 2 times 4 is 8. So 2 plus 8 is 10. So 4, we should have 10. And that pattern works, so it's 2 plus 2n. On the next page, I want you to try that. Okay. And then we've got an exit ticket after. All right, and our last portion, so the exit ticket. Does the graph represent a linear function? Explain. You should have put no, because it is not a straight line. All right, here's your homework. Good luck.